Okay, so today we're diving into CVecchia, and it seems to be tackling a pretty big challenge in Gaussian processes, especially when you're dealing with those like massive data sets.
Yeah.
You've probably encountered this yourself, right? Where you're trying to run some analysis and it just feels like it's taking forever.
Absolutely. I mean, Gaussian processes, they're such a powerful tool, and you see them everywhere, statistics, machine learning, you name it. But the thing is, when you start working with these huge data sets, they can become really computationally expensive. And that really slows things down. It's a major bottleneck, not just in research, but practical applications too.
Yeah, it's like you're trying to drive a race car down like a narrow, congested street. You have all this power, but you just can't go anywhere. So is that kind of where CVecchia comes in? Is it like clearing a path for these Gaussian processes to actually reach their full potential?
Yeah, that's a great way to put it. So this paper that we're looking at, it really dives deep into this new method, CVecchia, and what it's all about is making Gaussian processes way faster, like lightning fast,
Mm.
but without losing that accuracy. Even with these massive data sets, I mean, it's a game changer.
Okay, so let's unpack the CVecchia thing a little bit. I'm trying to picture it in my head, right? Like imagine you're trying to speed read through, I don't know, a really dense textbook. You want to get the main arguments, the core ideas, without getting bogged down in every single detail.
Right.
Is that kind of what CVecchia is doing for data analysis?
You nailed it. It's like, imagine if you could just highlight the most important sentences in that textbook. Just the ones that really capture the essence of the arguments. You'd still be able to understand the main ideas without having to read every single word. And that's what CVecchia is trying to achieve. It's all about identifying and focusing on the relationships in the data that truly matter.
So it's like finding those shortcuts, those like critical connections within the data itself.
Yeah.
How does CVecchia actually do that? What makes it different from the other methods out there?
Well, the really fascinating thing here is that CVecchia uses something called a correlation-based distance, right? So instead of just looking at how far apart data points are in a traditional sense, like their physical distance or the time difference between them, it considers how closely related those points are based on their correlation. Like, just because 2 points are far apart in time or space doesn't mean they're not connected in some other meaningful way.
Oh, I see.
It's kind of like, two chapters in a book.
Yeah.
They might be physically far apart, but they could be deeply interconnected in terms of their themes, the ideas they're exploring.
So it's not just about proximity, it's about those meaningful connections within the data. That's really interesting. And does this correlation-based approach, does that actually make a difference when it comes to accuracy?
Oh, absolutely. By focusing on these correlation-based distances, CVecchia can zero in on the relationships that really drive the patterns we see in data, even when those relationships are not obvious at all, not linear. And that leads to much better accuracy, especially when you're dealing with these complex data sets, the kind that we often see in the real world.
Okay, I'm starting to see why this is a big deal. Now, is this method limited to certain types of data, or can we just throw anything at it?
That's what's really exciting about CVecchia. It's incredibly flexible. It's not just a one-trick pony. It can be applied to all sorts of data. Weather patterns, stock market fluctuations, you name it. Basically, as long as there's some kind of correlation present, CVecchia can likely uncover it and use it to give you a more accurate analysis. And this paper really highlights that versatility.
Okay, you've definitely got my attention. They actually put CVecchia to the test, right?
Oh.
Ran some simulations to see how it stacked up against other methods.
Right.
So they put it through its paces, huh? What kind of simulations did they run?
Well, they really wanted to challenge CVecchia, right?
Yeah.
So they hit it with anisotropic data,
Okay,
where the relationships change depending on which direction you're looking at.
right.
Like, think about how pollution spreads. That's often affected by wind direction.
Oh,
So it's not uniform.
right.
And then they also threw in non-stationary data.
What's that?
So that's where the patterns, they kind of shift across different regions or time periods. You can imagine, like, housing prices, how much they vary from neighborhood to neighborhood.
Yeah, it makes sense.
So they're not stationary, they're changing a lot.
Mm-hmm.
Yeah, and they even threw in data that was both anisotropic and non-stationary.
Oh, wow. Really put it to the test.
Yeah.
And how did it do?
It passed with flying colors. This paper shows that it consistently outperformed the other methods out there, especially when dealing with those more complex data types we were just talking about.
Interesting.
But it wasn't just about accuracy. Remember, CVecchia was designed to be faster, more efficient too.
Right. So did it actually strike that balance? Like, was it both accurate and efficient?
That's the amazing thing it was. It managed to achieve these really impressive gains in accuracy while being significantly faster than those traditional approaches. It's that combination that makes it so promising for tackling these really large-scale data problems that we're facing more and more these days.
Yeah, that makes a lot of sense. Now, this paper doesn't just stop at those simulations, right? It goes a bit further and applies CVecchia to something called a Gaussian hierarchical model. And I have to admit, that sounds a little intimidating to me.
Sure.
Can you break that down a bit? What exactly is that?
Yeah, so think about a family tree. You've got all these different individuals, right?
Yeah.
And they're related at different levels of closeness. You have your immediate family, and then you've got your cousins, aunts, uncles, and so on. That's kind of how a hierarchical model works. It represents data in a similar way, showing those different levels of relationships within the data.
Oh, so it's like we're analyzing a whole family reunion now, not just individual people. Yeah.
Exactly. And what's really cool is that CVecchia, it actually excels even in this more abstract setting. So it shows that it can handle not just those traditional data sets, but also uncover those complex relationships in data that's structured in this kind of hierarchical way.
So we're not just talking about speed here, we're talking about understanding,
Exactly.
like a deeper understanding of how things are connected.
Yeah.
Okay, well, this is all really interesting, but I think it would be helpful to see how all of this actually plays out in a real-world scenario. Did they apply CVecchia to any practical problems?
They did. In fact, they chose a challenge that I think we can all relate to, predicting the weather.
Oh, okay.
And not just any weather. They used this huge data set from the North American Regional Climate Change Assessment Program, NRC-CAMP for short.
Right.
And they specifically looked at predicting daily high and low temperatures for a region in the southern U.S., which is known for its pretty fluctuating temperatures.
Yeah, I've been there. Definitely some wild swings.
Exactly. So they basically fed CVecchia a mountain of climate data and said, okay, show us what you can do. Can you predict these temperatures?
And what were the results? Was CVecchia as good as a weatherman? So, drumroll please, how'd CVecchia do with those southern temperature swings?
It nailed it. Actually, it ended up outperforming the other methods they tested, giving the most accurate predictions for those daily temperature changes. And that's a big deal, because even if you can just improve the accuracy a little bit, that can have a huge impact. I mean, think about planning for energy demands or getting ready for extreme weather.
Yeah.
Those small improvements can make a real difference.
Yeah, absolutely. So we've gone from like just speeding up analysis to potentially improving things like, I don't know, weather forecasting, resource management, all sorts of stuff. This feels like more than just like a faster algorithm,
You're right. It's a different way of thinking about how we analyze complex data. CVecchia isn't just crunching numbers faster. It's actually revealing those hidden connections, those subtle relationships that we might have missed otherwise.
It's like it's giving us a whole new perspective, highlighting how interconnected everything really is. And it makes you wonder, like, what else can we do with this? The paper mentioned some other possibilities, right?
Oh yeah, tons. Imagine, for example, robots that can learn multiple things at the same time, like a super efficient multitasking machine.
Okay, hold on. Are we talking about robots that can, like, clean the house, A&D, cook dinner, A&D, fold laundry, all at the same time?
That's the idea.
Yeah.
It's called multitask learning, and CVecchia could be the key to making that a reality.
Wow.
And it's not just robots. Think about how much we rely on those virtual assistants, like the ones we talk to every day on our phones and stuff. CVecchia could totally revolutionize that whole field, too.
How so?
Well, because it's so good at finding those hidden connections in huge data sets, it could lead to much more, intuitive natural language processing. Those interactions we have with virtual assistants, they could become way more seamless, more human-like.
That's pretty amazing. We've covered a lot of ground in this deep dive, from speeding up these Gaussian processes to, like, revolutionizing robotics and AI. It seems like this CVecchia thing has the potential to, really change things.
It definitely does. And I think it's a good reminder that we're living in a time of incredible discovery, especially when it comes to understanding and using data. CVecchia is a perfect example of human ingenuity, our ability to not just analyze information, but actually extract real meaning from it.
And that's what makes it so exciting. It's not just about the numbers themselves. It's about the insights we can gain from those numbers, the deeper understanding we can get.
Exactly. It's about pushing the boundaries of what we know, finding those elegant solutions to complex problems, and hopefully making the world a smarter, more efficient, and just a better place.
I couldn't have said it better myself. Well, that about wraps up our deep dive into CVecchia. If you're interested in this kind of stuff, the cutting edge of data analysis and how it's shaping the future, you know where to find us. Until next time, keep on exploring.